Welcome, Algebra 2 students. We're going to be in Lesson 43 today. So we are starting to get into the harder stuff in Algebra 2, into the real meat of the book. We are a third of the way through the book, which means all the review is over. Now let's jump into some new fun math. So with that said, we're going to talk about sine, cosine, and tangent. I know you've heard those words before, and you're probably going, oh, that sounds really, really hard. It's really, really not. It's really not. It's just all about right angles. Or not right angles, right triangles. Okay? Now, for instance, we are going to look at 3 right triangles that all have one angle that is 30 degrees. All right, and these are all right triangles because Miss Tracy said they were. And because this little corner right here is 90 degrees. I'm going to put in these measurements right quick for you. I guess I could have had this done ahead of time, huh? All right, so first thing we're going to talk about is the pieces of the angle. So we have a hypotenuse here, and then we have 2 legs. And when I say that something is opposite an angle, like for instance, the hypotenuse is opposite the 90 degree, the right angle, it means straight across from it. So this side would be opposite of this angle, and this side would be opposite of this angle, right? So we understand the opposite of an angle. Now let's talk about an adjacent angle. In talking about this 30-degree angle, the hypotenuse is always called the hypotenuse. It is never called an adjacent side. The adjacent side is going to be the side that makes that angle that is not the hypotenuse. Okay? So this would be the adjacent side, this would be the opposite side, and this is always the hypotenuse. So that being said, let's look at the measurements of these triangles. If you remember proportion and ratios, we are going to look at a ratio called sine. And the sine is simply the opposite angle over the hypotenuse. Hypotenuse, I can spell it. So the opposite side divided by the hypotenuse. Now, if we look at these, we can see the opposite side here is 2 over 4. And the opposite side here is 60 over 120. And the opposite side here is 120 over 240. And if we look carefully at all of these ratios, we see that we can reduce those to 1/2. And if we were to put that in decimal format, that would be 0.5. Now, if you'll take your calculator out, let me get my calculator to start up here. You can see if I type in 30 sine, I get 0.5. So I can type in the degree of an angle, and it will tell me, if I click sine, it will tell me the ratio in a decimal form of the opposite side divided by the hypotenuse. So it's very handy when you have the measurement of the hypotenuse, but not the measurement of the opposite side. Let me show you what I mean. If I have a sine of 30 degrees, and I don't know what the opposite side is, so that's the opposite, but I know the hypotenuse is 4, right? Here's the hypotenuse. I don't know what this is. We'll pretend I don't know that that's 2. So I go to my calculator and I type in, okay, what is the sine of a 30-degree angle? I go 30 sine, okay, that's 0.5. So 0.5 equals the opposite side over 4. So in order to undo this, I need the inverse operation of division. And the inverse operation of division is going to be multiplication. So what I'm going to do is I'm going to multiply both sides by the hypotenuse. Right? We've done this before to solve for a number. So I'm going to say times 0.5 times 4, that's going to be 2. 2 is going to be equal, it'll cancel on this side, the opposite side. What is the opposite side? It's 2. See how that works? So this is how you would solve for finding the opposite side. So if you don't know the opposite side, you're going to use sine. Okay? Now, let's talk about, so you need to put all of this in your notes. Okay? Do that now. I'm going to go ahead and erase this bit right here. So now let's talk about something called the cosine. The cosine is the adjacent side. And I guess I should spell that out for you guys. So adjacent, A-D-J-A-E-C-E-N-T, adjacent side. Now remember which one is the adjacent side, and that is over the hypotenuse. All right, I'm going to go back to the same triangle. The adjacent side is the other side of the triangle that's not the hypotenuse that helps make up the angle that we have the measurement for. So in this case, it's 30 degrees. So the cosine of 30 degrees would equal the adjacent side, which I just usually write ADJ, and we know the hypotenuse is 4. Right? So we use cosine when we don't have the adjacent side. So that would be adjacent is what? So we plug it into our computer, or I keep saying computer, we plug it into our calculator. We clear this. We say 30, and the COS is cosine. That's a big long number, right? But we do the same thing that we did down here, and we do the inverse operation of division, which is multiplication, and we say times 4 equals 3.464. 3.464. Now, most of the time, we're going to say, just give me 2 decimal places. Sometimes I might even say, just give me 1 decimal place, and you would round that up to 3.5. It depends on who's asking the question, whether it's me or the book or the ACT. But that is how you would find the missing adjacent side. If you have the degree and the hypotenuse, then you can find the opposite side with sine and the adjacent side with cosine. Okay? All right. So let's move on. I'm going to go ahead and write that here so you can see that would be some crazy number. Let me write it. What was it? 30 cosine. Let's round that to 0.87. So 0.87 equals the adjacent over 4, right? Now, if we do this and we say times 4, then we get the big long number. But if we just use the rounded number that we had, times 4, we get a little bit different response. So it's much more accurate to go ahead and do 30 cosine, and then while it's already on the calculator, then do your multiplication. Then you can do whatever rounding you want to do, right? Instead of doing this. But for the sake of showing your work, you could just write 0.87 but not clear the calculator. What I mean by that is this. 30 cosine. Okay, I'm going to write 0.87 here and do this. Now I'm going to go ahead and do my multiplication. All right, 3.464. All right, so the 3.464 is equal to the adjacent. You see how I did that? I just wrote a shortened version, but then got the actual number on the calculator and wrote the actual number here. So it depends on how many decimal places you want to write down, is what I'm saying. All right, so when you need to find the adjacent side, you need to use the cosine. If you have the hypotenuse and the degree of the angle, you can find the adjacent side with cosine. All right, let me make this a little bit smaller. This is for the adjacent angle, if you need to know that. All right, so we have one more to talk about, and that's tangent. So with tangent, that's this right here, T-A-N-G-E-N-T. We are looking for the opposite side in relationship to the adjacent side. And I can't spell adjacent. There we go. So, if you need to know the adjacent side and you don't have the hypotenuse, then you are looking for the tangent. Okay? So this is when sine is you need the opposite side and have the hypotenuse. Okay? Tangent is when you're looking for the opposite and you only have the adjacent. Let me change this right here. And you have the adjacent, right? So we're going to do this the same way. We're going to pull up our tangent in the calculator. We're going to say 30 tan. That's our tangent. And this looks like about 0.58 for tangent. So I would write 0.58 for a tan of 30 degrees is 0.58. And my my opposite is the one I'm looking for. And my adjacent, I have that. My adjacent is 3.464. So what am I going to do? I'm going to multiply both sides by 3.464. I'll multiply this by 3.464. So I pull out my calculator. Then my tangent is still in there, so I'm going to multiply by 3.464. 1.99999 rounds up to 2. Isn't this 2? It is. And if I had said 0.58 like I had written down times 3.464, I would have gotten 2, right? You see how rounding that up, it would look like a 2. Rounding the other up would look like a 2 as well. So that would be the answer I would put. I would round it to 2. So that's how you would find the opposite side. So that would be 2 equals the opposite side. And you use tangent when you're looking for the opposite, but you don't have the hypotenuse. You only have the adjacent side. All right. So I hope that that is clear. We've gone through how to find it on the calculator. Now, how in the world, Miss Tracy, do I remember all of these? There is a mnemonic phrase that helps you to remember, and it is called so, ka, toa. And it literally means sine equals opposite over hypotenuse. That's the so. Ka is cosine equals adjacent over the hypotenuse. And toa is tangent equals opposite over adjacent. Okay, so if you can remember so, ka, toa, then you can remember these formulas. And remember, you're always looking for the number on the top, given that you have the information on the bottom. Okay, that is how it works. You're looking for the top number, you have the bottom number, and you can find the sine, cosine, and tangent for the degree of that angle on your calculator. Okay? And we type in the number, you type in the angle, you type in the degree of the angle, and press the key. And that gives you the sine or the cosine or the tangent. So you're going to want to put all of this in your notes. And you're also going to want to put, let me use this little last one here as an illustration. This is the hypotenuse. Okay. And then this would be the opposite. And this would be the adjacent. Now, if you have, we know that this is going to be 60 degrees here. Then this is the hypotenuse. This would be the opposite. And this would be the adjacent. So it's whichever leg is used to make the angle that you have the number for, that's the adjacent. The leg that is not connected to the angle is the opposite. So it depends on which one you're looking at as to which one is called which. And that is the best illustration that I can give you. All right, so that is all of lesson 43. But I have a couple of practice problems, some example problems to do. So if you don't have this all written down, pause me now and write it down. And then I'm going to clear the page and move on to our practice problems. All right, so let me draw a right triangle if I can. There we go. And I'm going to put some degrees, some measurements in here. So this is 4, this is 7, this is 5.74, and this is A. All right. We will use our SOHCAHTOA to figure out what we have here. So let's look at the first triangle. This is the first triangle. We have two more after this. And we're going to use our mnemonic SOHCAHTOA to help remember the definitions of sine, cosine, and tangent. And we'll use a calculator to do the divisions. All right. We're going to first find the sine of A. and then we're going to find the cosine of B, and then we're going to find the tangent of C. And we're not going to use our calculators. All right, that's the whole point of this. So ka toa. So for the sine, we know that that is going to be opposite over hypotenuse. So our opposite, this is the angle, so our opposite is going to be 4, and our hypotenuse is 7. All right, so now we can use our calculator. And we're going to say 4 divided by 7. Okay, that's 0.5714. Let's round that to 0.57. Approximately 0.57 because we rounded it. All right, remember when we round, we say approximately. So approximately equal to 0.57. So let's pull up our calculator and check it and see if we got that right. So if I put in, oh, never mind, I don't have the degree measure of the angle. So that kind of stinks. All right, so let me do the cosine. So the cosine is equal to the adjacent over the hypotenuse. So the adjacent angle for here is going to be 5.74 over the hypotenuse of 7. So that's going to be approximately 5.74 divided by 7 equals 0.82. So that is approximately equal to 0.82. Actually, I think that was equal to it was equal. So there is no approximation here. This was absolutely equal to 0.82. All right, so now we are going to do the tangent. So the tangent is equal to opposite over adjacent. So that is equal to the opposite is 4 and the adjacent is 5.74. So that is going to be, let's clear that out, 4 divided by 5.74. Let's round this up to 0.7. That'll round to 0.7 pretty easily. So let's say approximately 0.7. All right. So now we're going to look at finding the SOHCAHTOA, the sine, cosine, and tangent of another triangle. So let me put that in. So here's another right triangle. And we are going to find, let me put in our dimensions here. This is the angle B that we're talking about, 8.6. This is 5, and this is 7. So our sine is opposite. So our opposite is 5 over the hypotenuse of 8.6. Our cosine, let's go ahead and do that. Our adjacent is 7 over the hypotenuse of 8.6. And our tangent is opposite over adjacent, so 5 over 7. You see these all are just proportions, and then we use the calculator to do the division. I'm going to erase that just in case. All right, so here we go. Here's our calculator. So now we can do, hello, come back up here. I lost it. All right, so 5 divided by 8.6 equals approximately 0.58. Approximately 0.58. Okay, so let's look at our cosine of this triangle. So that's 7 divided by 8.6. So it's approximately 0.81. So approximately 0.81. So let's look at 5 divided by 7. Clear that. 5 divided by 7 is approximately 0.71. So approximately 0.71. It's approximately equal to that. All right, we have one more triangle that we're going to do these exercises on. All right, and the dimensions here are 10. Oh, I need a pen. 10, 6, and 8. And we are going to worry about this triangle, or this angle C right here. All right, so our sine is our opposite over our hypotenuse, right? Opposite over hypotenuse. So that is going to be, the opposite is 6 over 10, right? Our cosine is adjacent over hypotenuse. So the adjacent is 8 and the hypotenuse is 10. Our tangent is opposite over adjacent, so that's 6 over 8. Okay, so let's do 6 over 10. First, I have a pretty good idea what that is. 6 divided by 10 is equal to 0.6. It's equal to 0.6, so we can put an equal sign. It's not rounded. When it's not rounded, you can use the equal sign. Okay, 8 divided by 10 is 0.8, so equals 0.8. Because we did not round anything. All right, and now 6 divided by 8 is equal to 0.75. All right, so we have found the sine, cosine, and tangent for each one of these triangles given the dimensions. Now we should understand how to find and what SOHCAHTOA really means. SOHCAHTOA is the ratio of one side to the other, depending on what information you have. So let's look at, that's actually all we're going to do with sine, cosine, and tangent right now. Let's look at some inverse functions. And then we have one problem to do. So let's clear this. And inverse functions are going to help us solve these. So we're still talking about sine, cosine, and tangent, but we're not doing more triangles. So the inverse sine of a number is the angle whose sine is the number. So for instance, the sine of 30 degrees is 0.5. So the inverse sine of 0.5 is 30. Okay. The cosine of 30 degrees is approximately 0.866. So the inverse of 0.866 is 30 degrees. The tangent of 30 degrees is approximately 0.577. And I will say that the more decimal places you use, the more accurate your number will be. So the inverse tangent of 0.577 is 30 degrees. So you see how that kind of works? It's just the inverse sine, you flip it. The inverse sine of 0.5 would be 30. The inverse sine of cosine of 0.866 would be 30. So you're just flipping it and saying the inverse sine, the inverse cosine, the inverse tangent. That's pretty straightforward. All right, so let me clear this before I confuse y'all any further and do a practice problem. So we're going to find the angle whose sine is 0.643. All right. And the angle whose cosine, so we're looking for the sine, we're looking for the inverse sine of this number, and we're looking for the inverse cosine of 0.216. So what we're going to do, it's really straightforward. Let me pull your calculator up. And let me see if we have the inverse sine here. Do I have it on my calculator? My handheld? I wonder if I do or not. I do not see it. Oh, I do. It's the -1, sine to the -1. So clear this, and we're going to do the zero. We're going to do 0.643, and then we're going to tap inverse sine equals, and that is not right. So let me clear that. I'm not sure how to get it on this calculator, because maybe it's this. All right, all clear. Let's do that again. 0.643. Nope. All right then. I can't do it on this calculator. I knew this calculator had some limitations, and that's fine. But on your calculator in your hand, you're going to want to type, let me see, I have a TI 30XA, and it allows me to do a function, a second degree function. So I'm going to type 0.643, and I'm going to hit my second degree, and I'm going to do sine to the -1, which is the inverse. So if you have this button here that says sine to the -1, that is the inverse sine button. So for me, I can show you when we're in class. For me, it is a second degree function, so I have to hit a type of a shift key, but it's the little letters. Like I have a button here on my calculator that says sine, and right above it in bright green it says sine to the -1. Remember that is when you flip it. So like if you had 4 to the -1, it would flip to 1/4. This is the inverse of this number. Right? It's the inverse of 4. This is asking for the inverse of 4. That's what this is doing, is asking for the inverse of the sine. So if you have a problem that asks for the inverse of the sine in your homework, let me write that better, 0.643. What you're going to do is you're going to type the number, so 0.643, and then you're going to hit your shift key, and then you're going to press the sine -1 button. So let me do that again. 0.643, the shift key, which gives me the second menu, and then I hit the sine -1 button, and then my answer pops up for 0.01588744, We round that up as much as we possibly can, and that's going to be 40 degrees. And 40 degrees is the right answer. Okay? Same thing for the inverse of the cosine. We're going to type in this number into our calculator, 0.216. Then you're going to hit your shift key, whatever that looks like, 0.216. And then I'm going to hit my second or my shift key, and then I'm going to press the cosine to the -1, which is the inverse of the cosine. And that gives me 77.525798929. Oops. And that gives me, if I round this up to the smallest little digit here, that gives me approximately 77.53 degrees if I round it to 2 decimal places. And just do whatever your instructions tell you to do. It'll say round to 2 decimal places. It might say round to a whole number. If it says round to a whole number, then you would say approximately 78 degrees, just depending on what the question tells you to do. All right, so that is how you would find the inverse of your sine. So if you have the sine of a number, you can find the degree of the angle by using the inverse of the sine button on your calculator. And that will help you a lot. Alrighty, for when you need to find a degree, the other degree of a right angle, that'll help you figure that out. All right, so that is all we have for lesson 43. I know it's a lot to take in. Watch the video again if that's what you need to do, especially with this last little bit. Play on your calculator. Play with it. Press buttons, see what you get. Google the answer. Get on your calculator and say, okay, I have this sine. Type in the sine or 45 degrees and the sine. Write it down. Okay, then type in the number that you wrote down and the inverse sine button. Google that and see if that's the right answer. Ask Google, what's the inverse sine of whatever that number was? And it should match what you have on your calculator. So there's a way that you can practice and figure out how to use your calculator. You can also type into Google, depending on what type of calculator you have, you can say, how do I find the inverse sine on a TI 30X calculator? And you should be able to get instructions on how to do that for whatever type of calculator that you have. I know most of the time the directions for how to use a calculator just gets thrown out with the packaging. So that's a good way for you to figure that out. Just Google it. I promise you, Google is not completely 100% terrible. It can help you with this. All right. So I will see you guys in lesson 44.